ground source heat pump is going to be used to heat the front office space of our old existing building. It's about 5,000 square feet.
Okay. Or most people in Alaska don't have direct experience with a heat pump as a heating system, and the idea is a little unintuitive. I think the biggest thing we want to demonstrate is that heat pumps like this, they can work. They're an option in Alaska. You don't need to have fossil fuels on site, like oil or gas. That a heat pump is an option.
Because of our layout here, we couldn't quite fit a rectangle loop field onto this site. So the first two slinkies we put in actually do a 90-degree turn just to make the field fit better. So the field is kind of an L-shaped on this job, and the other four will be straight.
We couldn't put it just under the parking lot because anywhere where there's snow clearing, frost is going to penetrate deeper into the ground, and that could cause declining performance in the ground loop because the area around the ground loop is getting colder and colder and colder. So the solution here was to do a little bit of a unconventional geometry of a bit of an L, whereas more typically it'd be just like a rectangle or a square on the ground.
Drilling a hole so that we can put our PVC conduit down in there. That PVC conduit is going to hold our temperature sensors.
You wanted to go all the way, that thing was 4 feet 7 inches, Robin, you want it all the way at the bottom?
Perfect.
Okay.
We'll measure our tape when it goes in.
Great.
So we're going to take this relatively cold ground and heat a building. How does that work? If you don't know about how refrigeration systems work or even had direct experience with it, it might not sound like it's possible. But it's not only possible, it actually can be more efficient than other options or less costly than other options in the long run.
We've done several systems in town on just a tiny quarter-acre lot. In that situation, you do something different. You use a drill rig and you put in a vertical loop that doesn't take up any space to speak of. And no, it's a great application. What we're doing is we're fusing extensions on all the slinky loops. So there's 6 separate slinky loops, and each one has a 3/4 inch supply and return. And so what we're doing in this situation is we're bringing each one of those supply and returns from the individual slinkies all the way to the mechanical room, where they will have temperature sensors and can monitor leaving and entering water temperature for each individual slinky loop. And we'll come over with a polyurethane spray foam and spray the entire length of the parking lot here.
Once they finish the spray foam on the tubing, they'll just backfill all this and then they'll flatten out the field over there and they're done. And then sometime in August, I'm thinking, these pipes, they'll push them through the wall and do the installation of the heat pump on the inside of the building.
We have a high level of certainty that'll work in a place as far north as Fairbanks. How efficient is that going to be in the long term? And what kind of effect are you going to have on the ground? Are you going to be inducing a large area freeze, for example? So those are the primary questions we're looking at.